In this video, we will look at how to implement the largest rectangle solver in Mobius. Generate and test is a simple search strategy that can be used by solvers for finding solutions to various types of problems. In this case, we will look at how this strategy was used in the biggest rectangle problem. For this problem, the aim is to find the biggest edge-aligned rectangle in a convex polygon. For this implementation, local functions are used as a way of breaking down the code into smaller, more manageable chunks. In total, there are 6 local functions. The functions have been designed to work with one another, so the values returned by one function can be used as input parameters in another function. The local functions call one another in a hierarchical structure. The first function searches for the biggest rectangle in a polygon and calls next function. This function searches for the biggest rectangle on one edge and calls next function. And this function gets one rectangle at a specific point on an edge and calls the next function. Finally, this function calls a function that shoots a ray and finds the intersection coordinates. 2 other functions are simple utility functions. We will look at each function in reverse order, starting with the shoot ray function. The shoot ray function finds one intersection point between a ray and the polygon edges. The edge where the ray starts is excluded. Since the polygon is convex, it is guaranteed that there will be exactly one intersection point. This function needs to return more than one value, so the return values have been wrapped up in a dictionary. The dictionary contains 2 items, the intersection coordinates and the intersected edge. In the body of the function, a for each loop is used to loop through all the edges. For each edge, the ray and edge are intersected. If the result is null, then it means they do not intersect. If the result is not null, then the intersection has been found, and the loop can be exited. Notice that for calculating the intersection, an inline function intersect is used, with 3 arguments. The first 2 arguments are the 2 rays to intersect. The third argument specifies how to treat these rays. There are 3 options, 0, 1 or 2. 0 means that the rays are not infinite. In this case, the ray will act as a line segment, with a length equal to the length of the ray vector. The calculate edge or rectangle function finds one rectangle at a specified point on an edge. Note that this is not the biggest rectangle. It is just one rectangle at one point. The point on the edge is specified by a t parameter that varies between 0 and 1. 0 means that it is at the start of the edge. 1 means that it is at the end of the edge. In the body of the function, it shoots 3 rays using the shoot ray function. The first ray is perpendicular to the edge. This results in an intersection point. This point is then used as a starting point to generate 2 more rays, parallel to the edge. These rays are used to calculate 2 more intersection points. These 2 points are used for creating the rectangle, using some vector algebra. The calculate biggest rectangle on edge function searches for the biggest rectangle on one edge. The arguments the edge and the step size. The step size affects how many rectangles are generated during the search. The step size is actually the distance between the starting points of each subsequent rectangle. In the body of the function, the number of rectangles is first calculated, based on the step size. The function then loops, creating rectangles one by one. Each time it creates a rectangle, it calculates the area. If the area is bigger than the best so far, then it will be saved as the current best. The last function is the calculate biggest rectangle in polygon function. This function searches for the biggest rectangle in the polygon. The arguments are the input polygon and the step size. The function returns the 4 coordinates of the biggest rectangle that it found. In the body of the function, it loops through all the polygon edges. For each edge, it finds the biggest rectangle on that edge, using the calculate biggest rectangle on edge function. The loop is very similar to the previous function. If the area of the rectangle is bigger than the best so far, then it will be saved as the current best. In the previous functions, the generate and test strategy was used in 2 places: to find the biggest rectangle on an edge, and to find the biggest rectangle in a polygon. In both cases, the search is conducted using a for each loop. Before the loop, variables are created for storing the best performance and best solution. The initial best performance is set to some value that is guaranteed to be lower than any actual performance value. This way, the first solution found will immediately become the best. Inside the loop body, each solution is generated and tested. Testing the solution will result in a performance value. If the value is better than the current best, then the current solution will replace the best solution. Both the best performance and the best solution variables will be updated.